Welcome! CSEC Chemistry, May 2024 Paper 2, Solutions for Questions 4 to 6. Let's begin. Question 4. Magnesium and lead are metals often found in living things and in the environment. A. Part 1. Explain metallic bonding in metals. This is a force of attraction between cations, which are positively charged ions, held together by a sea of delocalized electrons that are freely moving. Part 2. Give the reason why metals conduct electricity in solid form. Metals conduct electricity because of the mobile electrons. Part 3. State any two harmful effects of lead and its compounds on living things and their environment. Possible answers include decreases plant growth and reproduction. Pregnant women may have miscarriages or stillbirth. Brain damage in children. Or you could write kidney disease and cancer in adults. B. A chemistry student conducted a series of experiments using an electrolytic cell to test the conductivity of magnesium chloride. The materials used to set up the apparatus and the student's observations were recorded in Table 2 below. For experiment number 1, PVC plastic was used as the electrode, while dilute aqueous magnesium chloride was used as the electrolyte. The bulb did not light and no visible reaction was observed at the electrodes. For experiment number 2, graphite was used as the electrode and dilute aqueous magnesium chloride was used as the electrolyte. The bulb was lit. Gases produced at the cathode and at the anode. Experiment number 3. Platinum was used as the electrode and solid magnesium chloride was used as the electrolyte. The bulb did not light and there was no visible reaction. Part 1. Explain why the bulb did not light in experiments 1 and 3. Experiment 1. PVC plastic was used as the electrode. This material is not a conductor of electricity. Therefore, electrons cannot move through the entire circuit, so the bulb did not light. Experiment 3. Solid magnesium chloride was used as the electrolyte. The ions are in fixed position within the crystal lattice structure and cannot move freely to conduct electricity. Part 2. Explain why the bulb lit in experiment 2. Graphite was used as the electrode. This material is a metal which conducts electricity due to mobile electrons. Dilute aqueous magnesium chloride was used as the electrolyte. This solution is a conductor of electricity due to the presence of mobile ions. Hence, electric current can pass through, causing the bulb to light up. Part 3. State the process that took place in experiment 2. The answer is electrolysis. C. Magnesium readily reacts with oxygen in the air. Write a balanced chemical equation for this reaction. Magnesium Mg solid plus oxygen O2 gas produce magnesium oxide MgO solid. You are required to write the state symbols. Now this equation is not balanced since there are 2 oxygens on the reactant side while 1 oxygen on the product side. In order to balance this equation, write the coefficient 2 in front of magnesium on the reactant side and 2 in front of the magnesium oxide on the product side. Now this equation is balanced. Question 5. A. Proteins and starch are examples of natural polymers which are formed through the process of condensation polymerization. Part 1. Define the term polymer. A polymer is a long chain-like molecule formed by joining many repeating monomers. Part 2. Define the term condensation polymerization. Condensation polymerization is the process where monomers react with each other and combine to form a polymer while releasing small molecules such as water. B. The manufacture of ethanol makes use of the fermentation process. Part 1. Define the term fermentation. Fermentation is the breakdown of substances like sugar anaerobically, that is, without oxygen, by yeast to produce ethanol and carbon dioxide. Part 2. Write a balanced chemical equation including state symbols to show the process of fermentation. The reactant will be glucose C6H12O6. The state symbol for glucose is aqueous. Glucose in the presence of yeast at around 37 degrees Celsius. You're going to write these conditions above and below the arrow. Produces ethanol C2H5OH aqueous plus carbon dioxide CO2 gaseous state. This equation is not balanced since there are 6 carbons on the reactant side while 3 carbons on the product side. Also, there are 12 hydrogens on the reactant side while 6 hydrogens on the product side. There are 6 oxygens on the reactant side while 3 oxygens on the product side. In order to balance this equation, write the coefficient or numeral 2 in front of ethanol and 2 in front of carbon dioxide. Now this equation is balanced. Part 3. Draw the fully displayed structure of ethanol. The prefix eth means there are 2 carbons, while the suffix anol indicates there is a hydroxyl group or OH group attached to one of the carbons. Lastly, draw bonds connecting hydrogen to each carbon. Ensure that each carbon has 4 bonds. Part 4. During a demonstration of the wine-making process in the school's food laboratory, a technician separated a pure sample of ethanol. However, the flask was not labeled and water was accidentally poured into the sample. Using a line diagram, draw and label the apparatus that could be set up in the chemistry laboratory to obtain the pure ethanol from the contaminated sample. Based on the mixture, the substances can be separated by fractional distillation. For the setup, the mixture would be in a container heated over a Bunsen burner. This container has an attached fractionating column that has a thermometer at the top to measure the temperature. A condenser is attached to the side of the fractionating column where the vapor will cool and condense into liquid form. A conical flask will be placed at the end of the condenser to collect the pure ethanol. Question 6. Alka-Seltzer and Epsom salt are common remedies used in the Caribbean. Alka-Seltzer is an antacid used to treat upset stomach, and Epsom salt is used to treat sprains and muscle pain. The active ingredient in Alka-Seltzer is sodium bicarbonate, NaHCO3, and in Epsom salt, magnesium sulfate. A. Water is called the universal solvent because it dissolves many substances. Epsom salt and Alka-Seltzer work by dissolving in water. Part 1. Explain why water is a good solvent. Water is a good solvent because it is polar. A water molecule consists of oxygen with a negative charge and hydrogens with a positive charge. Hence, water is attracted to other substances, also known as solutes, and the interactions cause the substances to dissolve. Part 2. State 2 properties of water other than it is a good solvent. Other properties include high boiling point, adhesion and cohesion, high surface tension, high specific heat capacity. Part 3. State any 2 other compounds that dissolve in water. You could write examples of ionic or polar compounds. For example, table salt, also known as sodium chloride. Other compounds can include vinegar, also known as acetic acid, glucose, or copper sulfate. B. Continuous use of Epsom salt in water may cause hardness of water. This does not happen with Alka-Seltzer. Part 1. State the type of water hardness caused by dissolving Epsom salt in water. The answer is permanent hardness because magnesium sulfate and the mineral content cannot be removed by boiling. Part 2. Explain why Epsom salt causes hardness of water. Epsom salt, also known as magnesium sulfate, causes hardness of water due to the dissolved magnesium and sulfate ions. The dissolved ions will not cause the water to lather, meaning foam, with soap, but form precipitates called scum. Part 3. Explain why boiling the water will not remove the hardness caused by Epsom salt. Boiling will not remove hardness because the magnesium sulfate is stable to heat, meaning it does not break down when heated. When the solution boils, Epsom salt does not precipitate out of solution. Only the water will evaporate and the hardness will increase. Part 4. Identify 2 salts that cause hardness of water and can be removed by boiling. Examples are calcium bicarbonate and magnesium bicarbonate. Part 5. When used as an antacid, Alka-Seltzer neutralizes the hydrochloric acid HCl in the stomach. Write a balanced chemical equation including state symbols to illustrate this process. For this equation, write the main ingredient in the antacid, which is sodium bicarbonate. The chemical formula is NaHCO3 solid state plus hydrochloric acid aqueous. These react to produce sodium chloride NaCl aqueous plus water H2O liquid plus carbon dioxide CO2 gaseous state. This equation is already balanced since there is 1 sodium on the reactant side and 1 sodium on the product side. There are 2 hydrogens on the reactant side and 2 hydrogens on the product side. There is 1 carbon on the reactant side and 1 carbon on the product side. There are 3 oxygens on the reactant side and 3 oxygens on the product side. Lastly, there is 1 chlorine on the reactant and the product side. This is the end of question 6. Thanks for watching. Don't forget to subscribe, like, and share. All the best!